All right, so now we're moving into the second day material, and here we're mainly going to focus on analysis. Luckily, the ArcGIS toolbox hasn't really changed much between ArcGIS Pro and ArcMap. So I think you'll find that the transition in terms of analysis will actually be pretty easy. Okay, so as a review of how tools are organized in ArcGIS, in ArcPro and ArcMap, they're set up inside of the toolboxes. So you have basically an ArcGIS toolbox, which has a bunch of sub-toolboxes, which can have even more sub-toolboxes and tools. For doing analysis on vector data, a lot of those tools are made available in the analysis toolbox. So doing things such as an intersection or a clip or a union, so on and so forth. Generally, that ships with ArcGIS Pro without having to pay an additional cost. For analyzing raster data, a lot of those tools are made available through the Spatial Analyst toolbox, so things such as raster calculator, Euclidean distance, doing math and zonal statistics on top of rasters. That generally costs extra, so you have to pay for that if you're wanting to have access to those additional raster analysis tools. So how do you get access to these tools in ArcGIS Pro? So all the analysis tools are available under the Analysis tab, and then from the Analysis tab you can access the tools. You can access or activate the tools pane. So just to show you a few examples here, if you click on Tools in Arc Pro, that will bring up the toolbox pane with all of the tools. This Environments option allows you to set processing environments and analysis settings. Model Builder, which we'll discuss at the end of the course, will allow you to open up a model builder and generate a model. The Python, which we're not covering in this course, that allows you to open up a window to type and execute Python commands. The History will provide a history of different processes and analyses that have been run in that specific map document if you want to go back and look at your settings or rerun something. Over here we have some access to some common tools in this tools area, so things like clip, intersect, buffer. This little drop down provides a set of common tools for raster analysis, and then this is one for feature analysis. There's a link over here to do network analysis and geostatistical analysis with the geostatistical wizard, and then some building of functions. So again, these tools are accessed in the Analysis tab. Again, the toolbox has not changed a whole lot. You can still use Model Builder and Python within ArcMap to automate or sequence analysis steps. You can still set up environment settings. You can access your analysis history, and you can even make your own toolboxes and scripts, similar to ArcMap. All right, so some notes on environment settings. First off, I find that it's generally a good idea to set environments prior to doing analyses, especially if you are working with raster data. So, for example, you can set your current workspace in Scratch Workspace. So that's going to be the default location, either a geodatabase or a folder where your output is going to be stored. In a map document, that's going to be the generated file geodatabase for the project unless it's changed. Again, the Scratch Workspace is more for where you're going to store like temporary output. You can define output coordinate system. When I do analyses, I generally think it's a good idea to just have all the data in the same projected coordinate system. You can set a processing extent. If you're working with rasters, you can set a step raster. So that's going to be basically an alignment raster. So all of your output will align to that raster so that the cells line up one to one. You can also define a default cell size and a processing mask. Again, that has to do mainly with raster data. Okay, so in the next set of slides, I'm going to provide some examples of some common vector analysis processes. One example being a table join. And then once we're through those examples, you're going to perform a table join to associate some deer harvest data provided by the West Virginia DNR to some county boundaries. Next, you'll perform a spatial join. So joining data based on a spatial location as opposed to a common or shared attribute. And then also select by location, where we're using spatial relationships between different layers in order to make a selection. So for example, here I'm selecting all the counties that intersect or have an interstate passing through them in West Virginia. So one of your tasks will be to find all the counties in West Virginia that contain limestone geology, and then find all counties in West Virginia that contain an interstate and also have an airport occurring in them. So in short, through some examples and tasks, you're going to get some experience working with and analyzing vector data.